morning, students. Today, I'm Chaitanya, Assistant Professor in Mathematics, working in Institute of Aeronautical Engineering, located at Dundigal, Hyderabad. Today, the topic of discussion is decision theory and the introduction and the basic concepts of decision theory. Let us look into the things with the help of slides. So, let us have a glance into the introduction of decision theory. Decision theory focuses on the problem of making decisions under uncertainty. So, in our real life, we'll have two kinds of situations. One situation is we are certain about the things, what going to happen. Like sun rises in the east, sun sets in the west. These are certain. You need not have any ambiguity over judging these things. And also, the timings you take lunch or timings you take dinner, all these things, most of the things are certain. But on the other side of the coin, we come across so many things in our daily life which are uncertain. That means we'll have some uncertainty what is going to happen, how to make a decision. So this kind of situation called random situations or situations of uncertainty. So decision theory means the techniques of making a good decision under uncertainty. This uncertainty arises from the unknown aspects of the state of the world the decision maker is in. That means when we are in little confusion, which decision we have to make, which will gives us the maximum profit or which will gives us the minimum loss. Okay, in that conflict, the decision theory helps us to make a decision. Okay, and the uncertainty can be modeled as a probability distribution capturing our belief about the world the decision maker is. So how could we use the mathematics in resolving this uncertainty? That means we must take the help of probability because we know probability is a measure of uncertainty, right? So we have to take the help of probability distributions and we have to pick up the correct probability distribution to model the prevailing uncertainty, and you have to use it to assess the probability, and on those we have to make the decisions. So in brief, we understood that decision theory depends on probability concepts and it helps us to make proper decisions under uncertainty. Now, okay, whenever we make a decision, it may lead to gain or it may lead to loss. So what happens if we face a loss when we have made a decision? The loss incurred by the decision maker can also be utilized for the optimal action selection. That means when the first time when we made a decision and we have incurred a loss, we need not be distressed or disappointed. The experience of that loss will makes us to take a good decision for the next time. That means the experience that we have acquired this time will helps us to take a better decision in the next time. That means it will leads us to minimize the loss when we are going to make a decision the same situation when it is repeated in the future. So most of the machine learning algorithms developed to focus on one of these aspects of learning and prediction. So in developing machine learning algorithms, okay, we consider this one of these either minimize the loss of information, or fitting the uncertainty with a correct probabilistic model. There are two things like head and tail of a coin. There are two things. One is either we have to minimize the loss of information while reducing the dimensions, okay, or we should fit correct probabilistic distribution model the uncertainty in the data analysis so that it will makes us to predict correctly the future results. So these are the two things which we mostly focus in developing the machine learning algorithms, either learning the probabilistic model or minimizing the loss. Okay, in probabilistic models, The process of obtaining desired model from the observations when it is not tractable does not consider the task of loss. So, while we focus on one side more, we have to compromise on the other side. The first side is to fit the probabilistic model with with maximum accuracy. The second thing is to minimize the loss. When we are trying to find more accuracy in the probabilistic model, we may have to compromise with the loss of information. Or if we are trying to minimize the loss of information as much as possible, then the probabilistic model we are fitting may be little wavy, okay, or little weak. So when we are trying to increase one thing, we have to compromise on the other side. Okay, so this is about a brief introduction on decision making. Now let us go to the definitions and the minimum basic fundamentals of the decision theory, and we'll discuss a few examples under which we'll take the help of mathematics in making decisions. So the concept of risk minimization and the probabilistic representation, that is the most important things in the machine learning community. So for machine learning, the decision maker uses a procedure that operates on data, produce a decision, then state and action space can be seen in machine learning. That means in machine learning, simply decision theory means he will adopt a procedure by using he could minimize the loss and he could find good probabilistic model on the data, and so that he could obtain good results, good predictions. Okay. Now, so in this diagram, you can see how decision theory has been decomposed into various components. First, to arrive at a decision, first we have to set our future condition. That means we have to set a precise goal, whether to minimize the loss or to fit a correct probabilistic model, or some things in some environment to maximize the profit, to minimize the time. Okay, like that we have to set up a precise goal, which is called set of future conditions. And then we have to list all the possible alternatives. That means what are the alternatives? What are the possible decisions in front of us? When we are in a situation of uncertainty and we have to make a decision, first we have to set up the goal, either to minimize the loss or to maximize the profit or to minimize the time. Some condition we have to set. And accordingly, we have to list out all the possible decision alternatives. Every decision will lead to a gain or loss, which can be represented in a number which is called payoff. So what is payoff? Payoff is the number. If it is positive, it says that it is going to give you a positive result. If the value is negative, it says that it is going to give a negative result. So payoff is the mathematical value which tells you by the corresponding decision whether you are going to occur loss or profit. So first we'll set up the goal, then we list out all the possible alternatives. We'll list out all the possible decisions in front of us, and we'll make a matrix with payoff values with corresponding to each decision. And by doing some mathematics on the matrix, we'll arrive at one optimal value on the payoffs, and correspondingly we'll select the corresponding alternative as the decision, and with that we'll try to achieve our future condition. So this is like a cyclic path. Okay, that means we'll set a goal and we list all the possible alternatives, decisions, and we'll assign a number to each alternative or decision. It may be positive or negative, and we do some calculations on that matrix, and finally, based on the calculation answer, we'll take a decision and we'll try to reach our goal which we have set up initially. Now, to use this approach, a decision maker would employ this process. In brief, we can divide the process of decision making in 5 steps. Step 1, identity possible future conditions or state of nature. That means what will be our future if we make a decision. Okay, that means a goal. We have to set up a goal. Develop a list of possible alternatives. That means we have to list all the possible alternatives or decisions or choices we have. What are the choices we can make? What are the decisions we can take? Determine the payoff associated with each alternate for every possible future condition. That means for this decision, this value, some value will be associated. And for if we make this decision, this value. Like that, we'll make a payoff. Positive means it is a profit, negative means loss. Estimate the likelihood of each possible future condition. By using some probabilistic formulae, we'll calculate the likelihood or maximum likelihood value. Of course, or some techniques. Of course, we are going to see in the next slides. By using those techniques, we'll come to a conclusion. And basing on the calculation, evaluate alternatives based to some decision criteria. Basing on the conclusion, a conclusion means it criteria. Basing on the criteria and basing on the conclusion we arrived at, we'll make a decision which will leads us to reach our goal. So this is the 5-step procedure which we apply in decision making. The information for a decision is often summarized in a payoff table. As I said earlier, what is a payoff or what is payoff table? That is a fundamental thing we must know. For corresponding to each and every decision we have to take, okay, there will be a payoff value which is a number, okay, or it represents the amount of information either we are going to gain or we are going to lose in terms of machine learning. That means the number tells you how much information gain you are going to have or how much information loss you are going to have. Payoff table. A table showing the expected payoffs for each alternative in every possible state of nature is called payoff table. Okay. Table. So the expected payoffs for each alternative, every possible state. That means if you comprise all the payoff values into a table, that is called payoff table or payoff matrix. Okay. There are several criteria like Maximin principle, Minimax principle, Maximax principle. Like that, there are several criteria which we'll discuss. And by using those criteria, we'll do some mathematical calculations, and we arrive at a decision based on criteria. Okay, that is what. So payoff table plays a vital role in decision making. So first, let us take a simple example. In a basic level to understand a decision making, how the payoff table plays a vital role. That's I'm going to discuss now. Here, suppose you're running a print. You're running a shop which with a printer and a photo start shop. Okay, there you'll need a printer, scanner, and a Xerox machine. Okay, it's a collaboration of printing, scanning, and okay. Now, with a small facility like a small machine, with a less capacity of machine, and there are 3 alternatives ahead of you. You are going to start a shop, a business with a printing and scanning and photo start shop. Okay, so you want to buy a machine for that. There are 3 alternatives. One is a small machine, that is a less capacity machine. Second one is a moderate machine with medium capacity. And third one is a large machine with more capacity. It depends on the center and the demand, whether to which machine we have to buy. If you are setting up our shop in front of small school, then small machine may be sufficient. But if you are locating your shop in a particular center, then we can go for moderate. But if you are setting up your shop in a big rush center in the city, then you can go for large facility. It depends on the number of schools surrounding your shop. Okay, so here when you set up a small machine, there will be 3. We can divide an year into 3 periods: low demand period, moderate demand period, and high demand period. Throughout the academic year, we'll have three stages. There will be very less demand in the month of May and April because schools will be off, and moderate demand in the months of Jan and Feb and Des. And remaining months you'll have high demand. So when you set up a small facility, you are going to have $10 of profit irrespective of the period, whether it is summer or winter or rainy. Okay, and when you set up a medium machine, you are going to have $7 of profit in the low demand, that is in the summer, and $12 of profit in the moderate demand, and $12 of profit in the high demand seasons. But if you go for a large facility means large machine. That means it will have it will have a chance of high running cost. When you have big machine, for each small repair you have to invest a lot of money. For each cartridges or whatever the raw material you have to use, you have to spend more money. So when you compare large facility during the low demand season, that is in the summer, you have to face -4. This is bracket 4 means -$4 per day, and moderate season you will get $2 profit, and high demand season you will get $16 profit. Okay, so now these are the figures associated with each decision. Decision means whether to buy small machine or medium machine or large machine. Okay, whether to buy small Xerox machine or moderate Xerox machine or big Xerox machine. And our situations, uncertain situations are low demand period, moderate demand period, high demand period. And the payoff values are +10, +10, +10, +7, +12, +12, -4 to 16. Okay. So in this situation, how we are going to use different criteria to make a decision, and there will be some mathematical and scientific procedure behind the criteria, which we are going to see now. Here, dollar means just not $10. He's telling that millions, $10 million, $7 million. That you have to understand. See, as we have already discussed, there will be some steps of procedure. First, identify the problem. First, understand the problem. Understand the level of uncertainty and specify the objectives, whether to maximize or minimize. What is the optimal thing that you are going to achieve, and develop suitable alternatives. List all the possible alternatives accordingly. Finally, analyze and compare alternatives. Compare the alternatives. Okay. Select the best alternative. That is the important. That means we have different set of alternatives, and for each alternative we have payoff values. So how to select the best alternative based on our payoffs? That is the mathematical process. Here lies the mathematics. These are just we'll do with our common sense. We'll understand the problem. Okay, we can analyze the problem by reading. Okay, by introspecting, and then we can set our objectives, and we can segregate all the possible alternatives. But the mathematics lies here, selecting the best decision and implement the solution. Finally, coming to a conclusion. Wanted to see the desired result is achieved. Finally, whether our goal is successful or not. Minimization or maximization. That is what we have to check. So these are the steps. Okay, right. Bounded rationality. This is one more important fundamental concept of decision making. Limitations on decision making caused by costs, human abilities, time, technology, and availability of information. So the uncertainty is due to because of these things. They are saying what are the things that makes us be uncertain, or costs. That means there are different challenges, like cost challenge. We have to minimize the cost. Human abilities with optimum human resources that achieve good results, and minimize the time. Within less amount of time we have to achieve the result. Okay, optimal time. Technology, while using the technical resources, we have to use them optimally. We should not use them more than the required or less than the required. We have to use them optimally. And availability of information, how much information we have, whether we need more or less, we have to. So in these particular situations we use decision theory. That is what he says, whether to minimize the cost, you have to apply decision theory, or whether to optimize the human abilities, you have to apply decision theory, or to optimize the time, you have to apply decision theory, to optimize the technical resources, you have to apply the decision theory, and to to minimize the loss of information and the availability of information, we had to apply the decision theory. Because of these limitations, managers can't always expect to reach decisions that are optimal in the sense of providing the best possible outcome. They might instead resort to asserts. So we cannot guarantee that every time we'll reach the optimal profit or optimal minimized loss or maximum. There may be certain variations. It depends on the practical situations. So we'll try to reach the maximal possible good decision, so that either we'll get a maximum profit or minimum loss. Okay, depends on the situations and the constraints that we are going to have. Yes, what are the environments now? What are the different environments under which we have to make a decision? There are three kinds of environment. They are broadly dividing. Certain environment with certainty. That means we are clearly know what is going to happen in that environment. Okay, we are fully aware of what is going to environment in which relevant parameters have known values. We know what for all the parameters we have fixed values. Like pi is 22/7, so we need not find anything that is fixed. So it is certain. Every parameter is certain, and we know the values. That is certain. So we need not make any decision in that. We can easily make the decision without doing any prior groundwork. So it is not of our interest. Environment in which it is impossible to assess the likelihood of various future events. This is the most important thing. Uncertain environment means where we cannot predict the results correctly in advance. We have different choices, but we are uncertain about what is going to happen exactly in the future. And environment at which certain future events have probable outcomes. That means risk. Risk means it's like either it may give either you big profit or big loss, and it purely depends on our intuition. Risk means it is very highly uncertain. Highly uncertain means either we can gain largely, or we may lose largely. So it purely depends on our intuition. Okay, so in uncertain situations only the decision theory works. In certain, we don't need a decision theory. In risk, we cannot apply decision theory. Only in uncertain conditions we can apply decision theory. Now let us take an example. Here again we are considering the same example which I have quoted in the previous slides, whether to buy a small machine or medium Xerox machine or a large Xerox machine. We have three uncertain situations, uncertainties, that is low demand period, moderate demand period, high demand period. Low means suppose you are setting Xerox and printing machine in a center where schools are located. Low demand means during June to December, and moderate means December to February or March. High demand means low demand means April and May, because exams will be completed, schools will be closed down. And from June to December you will have high demand, and from December to March you will have moderate demand. So these are the three situations. Now accordingly we have payoffs. Here $10 profit, $10 profit, $10 profit. When we have a small machine, if we are supposed to buy a small printing and Xerox machine, we are going to have any irrespective of the period, low demand, moderate demand, high demand period, we will have $10 profit. But if you go with medium machine, you will have $7 profit at low demand, $12 at $12 at moderate and high demand. So large facility minus $4. That means you will have a $4 loss and $2 profit, $16 profit. Now, how to make a wise decision? Okay, let us see some criteria which we practically apply to resolve this situation. What will you choose to build? The demand will be low, moderate, and high. Okay, under low demand, which decision will be correct? Under moderate demand, which choice will be correct? and under high demand, which decision will be correct? That's what he is asking. If the demand is moderate, choose to build the medium facility with a payoff 12 million. And if the demand is high, just build large facility with 16 demand. So these are the constraints we are having. Now, we have what are the different criteria in decision making under uncertainty. They are Maximin criteria, Maximax criteria, Laplace criteria, Minimax Regret criteria. So decisions are sometimes made under complete uncertainty. We are going to make decisions under completely uncertain environment. So that is why decision theory. For certain environment, we don't need decision theory. For risk environment, we don't need decision theory. Okay, now no information is available on how likely the various states of nature. So these four criteria, these are the mathematical criteria which we are going to apply to make a decision. Maximin, choose alternative with the best of the worst possible payoff. That means if you know that in the future you are going to have losses for a certain period of time, suppose we can take this example. Due to pandemic, corona, or second wave, you are going to have tough situations, up to 2 to 3 months. We have, okay. So for this three months period, we are going to have losses. Okay. So now you have to make a decision. What kind of decision? You have to select a decision which gives you the minimum of the maximum losses. That means among the various losses that you are going to occur, you have to pick up that decision which gives you the least loss. Okay, that is called maximin. Or maximin, you can understand it as when you are supposed to have least profits for certain period, then among those least profits, you have to select the maximum profit. Okay, that is called maxim. Maximax means when you are expecting the highest profits with the different decisions, like setting up a new machinery in the plant of Vijayawada, setting up new machinery in the plant of Warangal, setting up a new machinery in the plant of Karimnagar, setting a new machinery in the plant of Tirupati. So which decision you have to make? Only one place you can set up a new machinery. So you know that everywhere you are going to have profits. So which area you have to select? That means which area will give you the maximum of profits. That is Maximax. Everywhere you are going to have profits, but you will select that area where you are going to have higher profits when compared to others. And Laplace criteria, choose alternatives with the best average period. This is one more mathematical alternative, that is you will calculate the average of periods and you will select the maximum for over those averages, maximum average, and corresponding alternative will be the decision. And min-max regret criteria, that means when you know that you are going to face losses in your 4 business environments in the coming month, and you have to select only one choice. Okay, you have to make one of the 4 choices. Then you will write what are the maximum losses, and you will select the least among them. That means among maximum losses, you will select the least one, and accordingly you will make the decision. So there are 4 criteria: maximin, maximax, Laplace, minimax, regret criteria. So first let us look into the decision making using maximin. Here first we are selecting the we are selecting the minimum of 3 numbers in each row. When we buy a small machine, we will have $10, $10 profit. Among them, minimum is 10. Among second, when we buy moderate machine, we will have these payoffs. Among this, what is the minimum? 7. So minimum is 7. When we go for large machine, -$4, -$4, and $2, $16. So the minimum is -4. Okay. Now, what is our criteria? Maximin. Maxim means this is a minimum and this is a minimum profit we are going to have. This is $10 minimum, and here $10 minimum, and here minus $4. Among this, what is the maximum? Among this maximum is $10. So this is our maximum payoff. Maximum payoff. Okay. So maximum payoff $10 means you better buy a $10. That means you can go for $10 means this is the one. These are the one representing the decision of small facility. So this criteria suggests you that go for small facility, that means small Xerox machine, so that you will have every time $10 of profit, and you can minimize the loss. That is what maximum approach. So in the maximum approach, we always try to minimize the loss, and we'll try for always secured position. We don't want to risk, then we'll apply this procedure. So maximum will be a correct approach when we don't want to take risk and we want to play a safe game. Then we'll resort to this procedure. We'll select the minimum of each row, and among those minimum values we'll select the maximum value. Okay. Now, decision making under uncertainty, the second procedure is Maximax. That means under Maximax approach, how we can make the decision. Again, let us look into the table. With the small machine, these are the profits, $10, $10, $10 each. And with the medium machine, this is the profits, $7, $12, $12. In the low demand, moderate demand, high demand, 6 periods. And with the large machine, you are going to have minus $4 of loss, and demand is low. $2 of profit, moderate demand, $16 of profit, high demand. So by using Maximax, what we are going to do? So let us see. First, we'll select the maximum of these three numbers. What is the maximum? That is $10. And in the second row, what is the maximum of these three numbers? That is $12. And in the third row, what is the maximum? $16. Okay. So in the first row, we have maximum of $10. In the second row, we have maximum of $12. In the third row, we have the possibility of having maximum profit of $16. Now, what is our criteria? Maximax. Maximax means select maximum of maximum. Remember, I am elaborating that maximum of maximums. That means select the maximum of each row. Maximum of first row, maximum of second row, maximum of third row. Now select maximum of among these three values. What is the maximum of among 10, 12, 16? 16 is the Maximax payoff. Maximax payoff. So 16 lies here in this table. That means you better go for large facility, that means large machine, because it gives you large profit during the high demand, and hence in the future you can incur a lot of money. Okay, you of course there is a risk of having loss in the low demand period and very less profit in the moderate demand, but when you compare, that marginal difference between loss and this profit is $12, and difference between these two is $14. Sorry, this is $20. This is $14. So you can easily overcome the marginal differences, and you can have big gains. So if you want to risk, you can go for large machine, so that you are going to have maximum profits, highest amounts of profits. So when you want highest profit irrespective of risk and losses, then you will go with Maximax approach. So what are the two approaches we have discussed so far? Maximum means when we want to play safe game, we don't want to risk, and we want at least minimum profit in under any situation, then we go with the maximum. Okay, but Maximax means we are completely going with a daring decision. We always try to get the high stakes of profits. So for that, we will risk and we'll go with the highest payoff value, that is maximum of each row. Maximum of each row. That is why we always try to hit the highest profit, maximum possible profit. That is what the motive behind Maximax approach. And the third approach, Laplace approach, it's a very wise and more mathematical scientific approach. Let us see into this. Again, we have $10 and $10 at low, moderate, high demands with a small, and 7 for 12 with medium, and 4 -4 to 60 with the large machine. Okay. Now, under Laplace criteria, first we total the rows, that is 10 plus 10 plus 10, that is 30. $30 average, the sum. The sum of the amount is $10. Okay, and we'll take the average, that is $10. Okay, and we total the row, second row, that is 7 plus 12 plus 12, that is 31. Again, averaging it, we get 10.33 millions. So on an average, we are expecting 10.33 millions of profit. In the third row, we have -12 plus 2 plus 16 by 3. That is 14 by 3. That is 4.67. That means this 10 saying that you are going to have on an average $10 of profit irrespective of the period of demand throughout the year. Whatever the fluctuations in the demand, you need not worry. You will have a $10 million of average profit. That is what the average is saying, 10 is saying. Here, this 10.33 is saying, irrespective of the fluctuations in the demand, with the medium facility, if you go with medium facility, you are going to have on an average $10.33 million. Okay, and if you go with the large facility, then this number is showing that on an average, you are going to have $4.67 million of profit irrespective of the fluctuations. Okay. So, how to make the decision under Laplace? That means in the Laplace, we are calculating the average, sum by number, sum by number, sum by number. Now, we will select the maximum of these three average. What is the maximum of these three? What is the maximum of 10, 10.33, 4.67? 10.33 is the maximum. So, we go with 10.33 means we go with the medium facility. So, under Laplace criteria, how we are making decisions? Under Laplace criteria, we'll make decisions by averaging each row, and we'll select the maximum of each row, and corresponding alternative will be our decision order. Okay, so that is why Laplace transform gives you more mathematical way, scientific and mathematical in making decisions. Okay, under uncertainty, and the fourth and the last or criteria of making choice or decision under uncertainties, Minimax Regret. It is also wise and more mathematical. Let us discuss this. As we know that there will be $10 of loss, $10 of $10 of profit, $10 of profit, $10 of profit with small machine, irrespective of low demand, moderate of high demand. Similarly, medium machine 7, 12, 12. Large machine -4 to 60. Now, what we are doing, we are subtracting from each column. So we are from each column. Yes, we are from each column we select. That means from the first column we select the highest value, and in the second column we will select the highest value, and in the third column we will select the highest value. So what is the highest value in the first column? That means we are not going with rows unlike the previous criteria. Whether in Minimax or whether it in Maximin or Maximax or Laplace, we always calculate row wise and we'll go with the optimal decision. But here we are going column wise. That means we are selecting a biggest number in the first column, biggest number in the second column, biggest number in the third column. Now we will subtract the biggest number from each element in that column, in the corresponding entries of the column. That means 10 minus 10, 10 minus 7, 10 minus 4. That means we have selected 10 here, we have selected 12 here, we have selected 16 here. Now we subtract 10 minus 10, 10 minus 7, 10 minus 4. What are the answers? 10 minus 10 means 0, 10 minus 7 means 3. 10 minus 10 minus of minus 4, sorry, here 10 minus of minus 4, that means 14. Let me write it more clearly once again. Yes, I'll just repeat it once again. First we select the maximum of first column, the maximum of second column, maximum of third column. We'll write the numbers on the front, on the top of the each column, that is 10, 12, 16. Okay, now we subtract. That means 10 minus 10, 0. 10 minus 7, 3. 10 minus of minus 4, that is 14. And we subtract like this. 12 minus 10, 2. 12 minus 12, 0. 12 minus 2, 10. And we go like this. 16 minus 10, 6. 16 minus 12, 4. 16 minus 16, 0. So we have made a new table. See, we have constructed a new matrix. That means in Minimax Regret criteria, from the original data matrix, we'll build a new matrix, okay, which says that small facility, the marginal gain will be 0 to 6. Okay, and the marginal gain with the medium facility will be 3, 0, 4, 14, 10. Now we will select from each row, we will select the maximum. That means in the three, among these three numbers, we will select, suppose these three numbers, we will select the biggest one. These three numbers, we select the biggest one. In these three numbers, we select the biggest one. That means biggest among these three are 6. Biggest among these three is 4. Biggest among these three is 14. Now, I may again regret means we'll try to minimize the loss. Ultimate goal is to minimize. So when we want to minimize the loss or minimize the cost or minimize the time, then we apply this Minimax Regret curve. So Maximax, when we apply for maximization purpose, and maximum also we try to apply for maximization purpose. And Laplace criteria is also meant for maximization purpose, but Minimax Regret criteria will be is perfect for minimizing the loss or minimizing the time or minimizing the cost. So for whenever you want to minimize the things, you will apply this approach. So among these three things, which is the least one? 4. So 4 means this means medium facility at high demand is the correct definition, or that means medium facility it suggests, so that at any moment of time, whether there will be corona or non-corona or whatever the periods, what you will have, at least on an average, very least loss you will come out of the situation. That is $4 or $4 million of loss you are going to have under any situation when you go with the medium facility. So in order to minimize the choice, we'll always resort to this approach. That is Minimax Regret criteria. So decisions are made under the condition that the probability of occurrence for each state of nature be estimated. A widely applied criteria is expected monetary value. This is also widely applied. EMV criteria is also there, which will help us to maximize the profit. Let us see. EMV determine the expected payoff of each alternative and choose the alternative that has the best expected payoff. It is almost same as the Maximax. Of course, this approach is most appreciated when the decision maker is neither risk averse nor risk seeking. This of course, this is this approach should be applied when there is no chance of high risk. Okay, let us see this very quick. Again, we have taken the problem, but we are assigning some weightages here. Okay, for the weightage we fixed for the low demand is 30% and moderate demand is 50% and high demand is 20. That means we are expecting that throughout the year, out of 12 months, 30% of chance that there will be low demand throughout the year, and we are expecting that there is a 50% of chance that throughout the year we will have a moderate demand on an average, and there is a 20% of chance that there will be high demand throughout the year on an average. So we are assigning each uncertain component with a probability. That means the probability of having low demand throughout the year is 30%. The probability of having moderate demand is 50%. The probability of having high demand is 20%. Now we calculate the corresponding weighted sums, that is 0.30 into 10 plus 0.50 into 10 plus 0.20 into 10. Okay, that means 0.30 into 10 plus 0.50 into 10 plus 0.20 into 10. Okay, and we get $10 million. On an average, it is saying the $10 million. The expected value, the expected monetary value or expected profit. And 0.30 into 7, 0.50 into 12, 0.20, 0.30 into 7 plus 0.50 into 12, 0.20 into 12, that means $10.5 million profit on an average. Next, correspondingly, first weightage into number, that is 0.30 into minus 4, 0.50 into 0.20 into 16, that is $3 million on an average. You are expecting a monetary profit under large facility with this probabilities. Okay, that means we are fixing some probabilities, and under these probabilities we are expecting these profits: $10 on an average, $10.5 million, $3 million. Now, because among these three, the largest one is 10.5. This criteria suggests us medium facility will be the wise choice. So this is called EMB criteria. So by using several criteria, there are several criteria to make decisions under uncertainty. So under risk, you will prefer this EMB criteria. Under less risk, and we'll go with Maximax, and Laplace and Minimax Regret. So with this, I'd like to conclude the lesson, and in the next video, we'll meet with the continuation of this third module, and I'll thanks all of you for your patience. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.